Greetings to all. Welcome back to the course on Introduction to Electric Vehicles. So we are starting module 3. And module 3 we will be learning about the basic electromagnetic laws and the fundamental of AC motors. Then we will be going towards the popular motors which are being used in the electric vehicles and some of the potential motors which has the potential to be used in the future. And lastly, we will be going through the control schemes. So what are the control schemes used for controlling the motors? So let's first start with the fundamentals of electric or the electromagnetic theories. So first of the law, which is very important in case of motors especially, is the Faraday's law of electromagnetic induction. So what it says, before starting that what is Faraday's law, we will be going through the basics of a magnet. So here I have shown a magnet with the north and south. So we know that the flux wave starts from the north and ends at the south. So here also flux wave goes through like this, starting from the north and going through the entering into the south. So here you can see that when these flux lines are starting from the north and entering into the south, they are coming in contact of a coil. Which coil they are coming in contact? You can see here that the contact is being made. Contact. So this contact will be similar or will be same if the magnet position is not removed or the magnet position remains there. But what if the magnet itself is changing, or what if the coil itself is changing its position? So the Faraday's law says that every time whenever a conductor is exposed to a changing magnetic field, whenever a conductor is exposed to a changing magnetic field, there is a electromagnetic force induced. This we can see from this figure. Here we can see that a magnet is changing its position, and so with the changing position also the flux will be changing. The linkage or the flux linked to the coil will also change, and this change in flux will cause a rise in voltage. Okay, this change in flux will always create some induced EMF. So the expression for induced EMF is like this: E is equal to N is the number of turn. These are the number of turn 1, 2, 3, 4 and up to N into d phi by dt. So we have to remember one thing, that it is the change in flux which is important, not the quantity of flux which is important. Okay, so here the change in flux, or the speed of change in flux is more important. It is a d by dt of phi. So this is first law and it is very important law. Second law is our Lenz's law. Lenz's law is similar to Faraday's law, but it explains the direction of the electromagnetic force. Here in our case we told you that there will be induced EMF, but what will be the direction of induced EMF? That is important. So what will be the direction of induced EMF? That is dependent on the Lenz's law. Suppose the magnet is coming forward. So Lenz's law says that it states that the induced EMF or the induced EMF current which will flow in such a direction that it will oppose the change that induces it. That means this current direction which is being induced in the coil, this coil will be in such a direction so that it will be opposing the magnet. So the current direction is like this, and using a right hand thumb rule or a screw rule, we know that when the current direction is like this, the north pole is generated towards the direction of thumb. So if the direction of current which is being induced is like this, then the north pole will be generated here. Okay, and we know that north and north repel each other. So the purpose of generating north here is to repel the cause which itself is generating it. So it will always repel the cause, or it will always oppose the change that induces it. So now the complete expression for EMF induction is like this: N d phi by dt with a negative sign. So the EMF generated will be always in a negative direction, or negative in the sense to oppose the cause. Okay, these are the two laws. Now these two formulas or these two methods of Fleming left hand and right hand rule. These rules are especially used in case of motor, and right hand rule is especially used in case of generator. Here one thing is important, in left hand rule or in case of the motor, the conversion is from electrical energy to mechanical energy, and here in case of generator we are converting from mechanical energy to electrical energy. So in terms of electrical energy, we will be giving here voltage and current, and we will be obtaining some torque or force. Okay. So here when we will be using left hand rule, so this is the direction of B. B is the flux direction or the field direction. This I will be the direction of current in the conductor. Suppose conductor is placed like this and direction of current is like this and field is like this, then the force experienced by this conductor will be in direction upward like this. Okay, so you can use this thing, this finger will be representing the current, this index finger will be representing the B, and the thumb will be representing the force experienced by the conductor, this conductor. So this conductor, if this middle finger is the conductor and the current direction is like this, then the force experience will be towards the thumb. Similarly, the right hand rule will also work like this. Here we have shown us south pole and north pole, and we know that the flux or the flux flows through the from north to south. Okay, it will be flowing through the north to south, and the conductor is kept here. So whenever there is a motion in conductor, suppose the conductor is going upward, okay, so what will be the EMF generated? To know this, we'll be using our right hand. Okay, to find out the direction of EMF, we'll be using our right hand. So this direction, this index finger will be in the direction of the B, or the will be in the direction of the flux. So flux is going from north to south. Secondly, this thumb will be the motion of the force. So if the force we have generated in generator is like this and B is like this, then the direction of EMF or the direction of current is towards me. Okay, or this is the EMF direction. So these three rules, that is Faraday's law, second is our Fleming left hand and right hand rule, and Lenz's law. These all rules define how a motor works. So in next video we will be learning that what are the fundamentals of AC motors. So this is all for this video. Thank you.